This is Chapter 6, Wave and Sound. You are going to learn first about wave, secondly about sound wave, and thirdly about electromagnetic wave. There should be 3 separate videos. The first one is about wave, so let's see what is a wave. There are 2 types. The first type is called longitudinal. Okay, so in this case, that means the direction of the wave generation is parallel to the propagation of the wave. Okay, what do I mean by that? For example, if you have a tube with water, let's say here's your tube. Okay, and you have a membrane on this side, you have a membrane on this side, you fill up this tube with water. So what you do is you push it over here. And if the tube is short, when you push over here, you can feel it on the other side already. When the tube is long, when you push it over here, the molecule is going to compress and then release, compress, release all the way and propagate to the right side. So what happened is, your disturbance is in this direction. So that's the direction of the creation of the wave. And it's going to travel in the same direction as the propagation of the wave. So this is called longitudinal wave. An example of this one will be sound wave. Sound wave is a longitudinal wave. The other one is called transverse wave. That means the creation of the wave. Okay, so let's say this way. Over here, let's say you have a string, okay, and you fix this part on the other side. What happens is when you move your rope, this is your rope, when you move it up and down, you can see that the energy or the shape actually move to the right side. Okay, so when your disturbance is in this direction, up and down, but the propagation of the wave is not in the same direction but perpendicular to it, that's called transverse wave. An example of transverse wave is light wave or electromagnetic wave. I'm going to talk about few important key terms of the wave. Okay, so we need to know a few things. Okay, first of all, I'm going to put it into, I'm going to draw a wave. Okay, now if you look at the peak over here, this is a one whole cycle, because this cycle, if you move to the other cycle, they will look exactly the same. Okay, in math, this is called a periodic function. That means this is one period and you move exactly the same wavelength. That is another period. Okay, I just mentioned about wavelength. That means wavelength is the distance between these 2 peaks. Okay, not only the peaks, you can pick any similar point. For example, if you pick the valley over here and over here, still the same distance. Or if we pick any point over here with the same slope, they're the same. So we use this letter, it pronounced lambda, to represent the wavelength. Over here, this one is called amplitude. You can use the letter A to represent amplitude. How do I know which wave has more energy? So the energy of, or the intensity of this wave will be proportional to amplitude square. So intensity of the wave is proportional to amplitude square. Okay, all right, so the time that to generate one wave, one cycle of the wave is called period. So sometimes we use the letter T to represent period. Okay. There's a formula. So the speed, there's another one, speed. Well, there will be another one. It's called velocity. That's how fast this wave propagates. I'm going to give you a formula. Velocity is equal to frequency times wavelength. Okay. What is frequency? Frequency is how many cycles per second. That's called frequency. What is period? Period is how many waves. The time for that wave, how many seconds for that wave. So there's a relationship over here. So frequency is equal to 1 divided by the period. Okay, so let's focus on this formula. It's very important. You may have a quiz based on this formula. Okay, velocity that is equal to frequency times wavelength. For example, if I tell you that the velocity of a sound wave is 344 meters per second. That's the velocity of sound, typically in air. Okay. Frequency, let's say, frequency, I'm going to tell you that is 440. I haven't told you the unit yet. The unit is called hertz. What is hertz? Hertz is how many per second, okay? So for example, this is one wave, and if it oscillates, let's say 5 waves per second, and the wavelength is 1 meter, so how fast it travels? 5 times 1, it will be 5 meters per second. So if you plug everything in, you're going to get lambda, the wavelength, in the unit of meters. Okay, if you use all this standard unit, okay, velocity will be meters per second, frequency will be in hertz, then lambda will be in meters. Just want to solve this together. If I give you the frequency, if I give you the velocity, how do I calculate for wavelength? So wavelength will be equal to velocity divided by frequency. So you equal to 344 divided by 440. You have to use the right unit. If you use the right unit, then you end up with having meters as your end result. So I'm going to calculate it is 344 divided by 440 is 0.78 meters. That would be the wavelength. Okay. As an exercise, I want you to calculate, for example, if I tell you, this is your exercise, okay. If I tell you the frequency is 440 hertz, okay. And by the way, let's say it's not traveling in air, it's traveling in different pressure of air, not one atmosphere, okay. If I have different pressure of air, that means the velocity of the sound will be different. Let's say this is my frequency, and my wavelength is, let's say, 1.2 meters, okay. And what I would like to calculate is, so this one is frequency, wavelength. What is my velocity in terms of meters per second? Okay. Now you can stop the video and do the calculation.